Yes.
Thank you.
So you got a message saying that this is now live and we see attendance coming in. So I'm just going to give it maybe half a minute so that other people can sign in, and then I will quickly do an introduction and then turn it to Omar. Because the paper is the content that is important. I am going to cut short what I have to say as much as possible. Okay, let's start. Good morning, good afternoon, good evening. I think by now you're so used to this opening of morning, afternoon, and evening. Welcome to this session organized by IHEAR. The title of this session is COVID-19, Impacts on Household Economics, Inequality, and Poverty. We're very delighted to have four very interesting and timely papers that the authors will share with you. And for the participants, you can type your questions into the chat box. We will try to save some time for questions and answer. Each paper will be allotted half an hour. The presenter will first give about a 15-minute presentation, followed by an 8-minute discussion from the discussant, and we'll try to leave some time for Q&A. So without further ado, I want to introduce the speaker for the first paper. Speaker is Omar Galarraga. If I mispronounce your name, I apologize. And he'll be presenting on the epidemics and income inequality 2000 to 2019. Welcome, Omar.
Thank you, Winnie. Thank you for chairing the session. I will go ahead and share my screen.
Yes, please.
And put this in presentation mode. Can you see it okay?
Yes.
Great. So thank you again. My name is Omar Galarraga, if you can roll your R's. I am in Providence, Rhode Island. I am an associate professor at Brown University. This is joint work with Chris Thomas at the International Monetary Fund and Sharon Khalifa at California State University, Fullerton. So as you heard, the title is Epidemics, Pandemics, and Income Inequality. We wrote it last year in the middle of the pandemic, in the middle of the lockdown. And we were thinking, we were reading the popular press about all the effects potentially on poverty and perhaps on the widening income inequality. And we said, well, we have at least 20 years in our personal recent memory of other highly contagious infectious diseases. And so we could look into data about, what is the potential relationship between this presence of epidemics, pandemics, and income inequality. So that was the idea. We wanted to explore the effect on the Gini coefficient of the occurrence of a pandemic or an epidemic in a given country in a given year for basically the past 20 years, the first 2 decades in the 21st century. So if you don't have time to finish the presentation, I will just briefly summarize the main takeaways right now. We basically did a panel estimation with 191 countries with country and year fixed effects using a dummy variable. And we found that the dummy variable for a pandemic epidemic was significant and had a positive effect on income inequality, meaning that income inequality grew every time there was a pandemic or an epidemic. We were also concerned with potential endogeneity, so we implemented a 3-stage least square technique, and also using the 3SLS estimation, we also showed that the pandemic indicator had a statistically significant and positive effect of income inequality. All right, so going back to the beginning, a little bit of background. So there is not really, or we didn't find really a lot of strong theory behind this. Really, it was intuition based, and it was based on what the popular media was reporting. So we started thinking, the stay-at-home orders, the shelter-in-place orders for COVID, restrictions on in-person transactions, etc. I personally had been in Mexico in 2009 for H1N1, so I remember when the country shut down. And we started thinking, well, this could cause differential effects depending on socioeconomic status. And also, the losses of jobs could be also differential because many of the lowest skilled jobs cannot be done remotely. And so this was sort of the motivation for us to continue thinking about income inequality. Of course, many of the high-skilled jobs can be done remotely, and you could also argue that people with more skills can adapt more quickly with technological change, use of computers, use of internet, etc. We thought of other channels that are in the paper. The paper is available as a working paper through AEA and also at the University of York Health Econometrics discussion group. But there we also discuss about education channels in the short and the long term, right? In the long term is more clear where, if people are falling behind, the students are falling behind now, then there could be even more inequality later on. Again, technological use in terms of the computer, internet, other tools, also health status. As we've seen with COVID, many comorbidities such as cardiovascular disease, diabetes can exacerbate other infectious diseases. So we go more into the paper. For the sake of time here, I will go into methods. As mentioned, we had a panel of 191 countries. We used data from 2000 to 2018, which is the most recently, the most up-to-date information that we were able to find, including all the covariates, covariables, control variables that we use. And again, we wanted to examine the effect of epidemics, pandemics on income inequality. As mentioned, there have been several outbreaks, right? So there is MERS, H1N1, SARS, Ebola. And every time we saw one of those, we put a 1. If there was no epidemic or pandemic, we put a 0. And so equation 1 here shows you Gini coefficient for country I at year t as a function of the dummy variable, which is this EpiPan, and time t minus 1. So all of our models are with 1 year delay, right? Because we want to see, of course, the effect in the following year. So Gini coefficient IT as a function of beta, epidemic, pandemic, country I at time t minus 1. Similarly, the control variable vector x is also at t minus 1. And again, we have country fixed effects, time fixed effects. Very similar equation. Once we use the 3-stage least squares, we have the same equation 1 as we saw before, Gini as a function of the dummy variable, but we also add second equation where epidemic, pandemic is a function also of the Gini coefficient and an expanded vector of covariates z. In terms of the data sources, the data to identify the location and time of the highly contagious epidemic or pandemic came from the WHO, from data and statistics. As a summary, we have severe acute respiratory syndrome, 2002-2004 in a few countries. We have H1N1 in many countries, as I mentioned, including Mexico. We have MERS in Korea and other countries, Middle Eastern respiratory syndrome. We have, of course, Ebola, 2014 to 2016 in many West African countries, etc. From the WHO also, we have another outcome that we looked at, which was the fatality rate other exposure rather in the terminology of epidemiology, which was the fatality rate. So this was the number of deaths caused by the epidemic or pandemic divided by the number of cases of the disease in a country for a given year. In terms of the outcome of interest, here is Gini coefficient. We use the standardized World Income Inequality, is WIID database, version 8. This is a compilation of reported Gini coefficients from published sources. It's curated and includes all the data from OECD, another socioeconomic database for Latin America and the Caribbean, generated by CEDLAS and the World Bank, Eurostat, also World Bank's POP-CalNet, also the UN Commission for Latin America and the Caribbean, and many local country national statistical offices, etc. In terms of income inequality, the control variable vector x in equation 1, we use several variables, including GDP per capita. This we took from Penn World Tables, version 8. We have share of agriculture and labor force, share of agriculture, GDP, tax rate, inflation rate, consumer prices, trade openness, all of these from the World Development Indicators from the World Bank. Importantly, we looked also at democracy, the quality of political institutions. We take this from a Polity 4 project. We use specifically the Polity 2 score, which captures the political regime from a 21-point scale ranging from -10, strongly autocratic, to +10, which is strongly democratic. We also have Corruption Perception Index from Transparency International. Once we look at the expanded control variable vector z in equation 2, we add a few variables that are important, including population density, urbanization, democracy, and individualism. This is important because it's our identification strategy based on the intuition that high level of population density contributes to faster spread of disease, because perhaps isolated events, then because of the high population density can quickly become into an epidemic, and then obviously because of the travel into a pandemic. We also look at population density from the World Bank indicators in terms of number of people per square kilometer, and also urban population. We also use the Polity score as defined earlier, and in addition we use the individualism score from Goethe and Goffstede data set, thinking that countries with more individualism are less likely to have these public health measures like lockdowns. In terms of the results, we have here at table 1, which shows you all of the 100 countries for the 19 years that we have. We have over 3,629 observations. On average, the Gini coefficient is 39.5, going from 22 to 66. Fatality rate about 0.5. Epidemic dummy, we have basically 4.9% of the observations have an epidemic dummy. So 4.9% of the time we see an epidemic pandemic in these countries during these 2 decades. As you can see here, when we have the equation 1 without any covariates, the coefficient is 3. So the dummy coefficient of epidemic pandemic is 3, meaning that the Gini coefficient increases by 3 points without any covariates. Once we start adding the covariates, in the last model here in equation 8, or column A rather, it's still equation 1, but with all the control variables, is 2.8. So it's fairly stable no matter what we add. All of these is fixed effects, as we said, fixed effects at the country level with time fixed effects as well. Once we go into using the fatality rate, instead of using the dummy as the exposure, we use the epidemic fatality rate, and this doesn't work the same. In fact, once we have in column 8 all of the control vector the result is not significant. So only when we have the dummy variable as exposure, we see an effect on the Gini coefficient. Once we have the epidemic fatality rate, we don't see this effect. We believe this is because most of these outbreaks were controlled rather quickly. So we see the effect through having the epidemic sort of at the intensive margin rather than at the extensive margin in the sense of the fatality rate, because they were controlled fairly fast. Once we do the three-stage least squares, we see very similar result here. 5 is the epidemic dummy, the 5 points increase in the Gini coefficient, whereas we don't see an effect in equation 2. The Gini coefficient does not seem to have an effect on the epidemic dummy, meaning that we don't see the type of endogeneity that we were thinking there could be. Similar results for the epidemic fatality rate, but in the interest of time, I will stop now and look forward to any comments or questions that you may have. Thank you.
Great, thank you very much, Omar. And so let me invite Anna to do to discuss the paper.
Yeah. Hi. Thank you, Omar. You've made my job a whole lot easier. That's a very clear presentation. It's also a timely presentation, and I think while beginning from the title, I found the work quite provocative. Given the times that we live in, the consequences of the pandemic directly or sort of indirectly through the lockdown, the economic shock, all of that has led to just breakdown of many kinds of jobs, and the consequences of that are really, really quite large. And I think exploring that in a cross-country setting, I think is very pertinent, and I think it leads us to ask further questions, and I think that's the best kind of paper to be reading as one reads a paper. The paper is also sort of very clearly expressing the sort of standard sort of concern around endogeneity. It very quickly sort of gets into talking about this, and the paper very nicely sort of has a three-stage least squares framework. One can sort of sit down and ask for all kinds of other statistics, which I'm sure Omar would have at the back. So I'm not even going to ask about all sorts of validation questions. I have more substantive issues to sort of share and sort of raise, so that one stays in the domain in which I think the spirit in which the paper has been written. The broad finding I think that sort of I take away is that given an exposure to any of these kinds of zoonotical diseases that we've been seeing in the last 2 decades, there seems to be a very large impact on the Gini coefficient. However, this impact is not there if one is looking at a continuous measure of exposure, which would be the case fatality rate. And I think that's interesting. I mean, in a policy framework, I think it sort of re-emphasizes the kind of work that the WHO is trying to do, which is to try and address any kind of outbreak and not only large ones. So I think that's an important takeaway for anyone reading the paper. So what I'll do next in the minutes that I have is just share somewhat of a wish list. And I think it's shared in sort of an open spirit with sort of, whatever reactions you may have to that. So, while I think the endogeneity question sort of is handled appropriately, as a reader of the paper, I think it would have been interesting to sort of think a little bit more about the motivation for that endogeneity that the authors seem to be particularly worried about. I mean, at first pass, whenever one thinks of a pandemic, that's usually thought of as a natural experiment. I mean, there might be reasons to worry about the fact that it is not, and I think it would be good to sort of read what that is. I mean, certainly the lockdowns and certainly the way it was announced in India was very, very random. And so if there are concerns, I think it would be really good. I think given a cross-country setting, there might be concerns. It would be good to hear that. That's number one. The second sort of thing, again, as a wish list, the income inequality is very, very important. But given the sort of frame that we have, which is countries over time, a natural sort of concern that sort of arises is, what's the quality of the income measurement? And I do believe that all the data sources that you have looked at, the World Bank and all the other, the Swedish sort of data, they try to standardize this. But beyond the income inequality sort of question, there's also the fact that income, expenditure, and assets, and finally land, are all alternative measures of asset holding that could be going in very, very different ways, because the ownership of each of these measures of income or wellness in some sense go in very, very different ways. And I think some are perhaps much more sensitive, and I'll sort of talk about that. While reading this paper, this is my third point, I was reminded of a somewhat similar attempt I had, in which I was trying to regress health conditions on Gini. And I ran into a paper by Deaton, which was written in 2003 in the Journal of Economic Perspectives. And he was sort of very seriously discussing why Gini on the right-hand side may be a very, very problematic sort of regression coefficient to have. You have it on the left-hand side, so some of those concerns are not really relevant. I mean, he's worried about aggregating from the individual level to the country level. So he's saying that that aggregation process might capture this very problematic in a regression context. But one of the things that he does talk about there, which I think may be of interest, is the fact that the Gini coefficient is much more sensitive to top incomes changing rather than bottom incomes changing. And given that we are looking at pandemic times, our belief is that the top incomes are changing and becoming higher, as well as the bottom incomes are sort of also changing and going lower. So which part of that Gini calculation, so maybe something like a Thiel index as some sort of a robustness check may sort of actually be quite useful in this context. I've sort of not run a regression as yet, but I've been looking at subnational data within India. And I think in that context, I've been finding that some jobs have really grown significantly, while others have really lost out. And if one looks at Gini coefficients, which are occupationally indexed, they move around quite significantly. And so I think you do have a number of measures of the structure of the economy. I think that's really, really useful. If you could sort of add something which is around the nature of informality or the nature of contracts that people are mostly on, I think that may be an interesting margin to sort of look at heterogeneity in terms of impacts. Another point that sort of struck me, is that this nice sort of binary continuous variable way that you have of partitioning. If one were to, I was reminded of doing a bunch of cost analysis that I've done in the past with health cost data. And that's also similar when people are exposed to health shocks. Most people aren't, so it's zero. And then some people are, and then you sort of have a continuous variable, which sort of was leading me to think about a two-part model, which may be a way of sort of trying to see whether the current effects that you have, which is there's nothing on the continuous part, but there's a very large sort of 0 to 1 shot. If there is some sort of amelioration of that. So I don't know, it's a robustness thing. Finally, let's see.
Just conclude, yeah.
Yes, so one last comment that I had, which is if you were looking at governance measures, since pandemics tend to be, responses are at the local level, I was just wondering, as a governance metric, if you had anything which looks at the level of decentralization of policy making. And I think that might actually be quite a convincing sort of variable to have. You could also do a whole bunch of other things. I have a note for you, which I will email to you, Omar. So I'm done.
Great, thank you very much. there are some questions in the Q&A box. I thought that maybe I'll just read some of them and give Omar and maybe the co-authors an opportunity to respond to both Arnab's questions and also the participants' question. One question is that, have you tried to explain the effects of the pandemics on the income share of the bottom quintile instead of looking at the Gini coefficient? Another question from the same.
Should I answer?
Why don't I read you the questions,
okay.
And then if you can answer Arnab's and these together, that might be more effective. Okay. Yeah. The other one is, which you have already touched on, what are the channels that through which the pandemics increase inequality? You have discussed that. And the other comment is a bit long, is the internet. The spread of the internet at the beginning of the 2000s, to what effect it might have affected how you want to do your analysis, etc. So I'll stop here so that we can give Omar an opportunity to.
Sure. Thank you.
You want to?
Yes, thank you. There's the question on using the income share on the bottom quintile instead of Gini. We have not done that yet, so we will explore into that. Thank you for the comment. If the data are available sufficiently large, sufficiently complete, we will try that. The channels, yes, we did explore the channels, right? A lot of it is through job loss, what we're thinking, but also internet utilization. And as I mentioned, of course, education in the short term, long term, and health status differential comorbidity rates. And yes, the idea, the third question in terms of using sort of internet penetration, especially in the early 2000s, may be interesting, in addition to all of the other covariates that were mentioned by Arnab. Thank you so much, everyone, and especially Arnab for all the comments.
Okay, great. Are there other questions from the other presenters who are working on similar topic? Yes, David.
Very interesting paper. I guess just one question was, do you have the data to look at dynamic effects? Because it'd be interesting to see whether this is a one period shock and then it kind of goes back to normal, or whether this persists for a number of years.
I see, persistence, right? So say, okay, it's right now we just have one lag, but you're saying just lag it 2, 3, 4, 5, see if it stays. Yeah, we haven't done that, but we could test that. Thank you.
I guess I would just say you could do an event study approach, or I don't know if you have the data for that, or you could just figure out a way to plot an impulse response. Inequality data may not be available every year, though. That's why it's easier said than done, but it would be interesting if you could do that plot. Here's what happens. Here's the impulse response of a pandemic shock to inequality.
Yeah, it would be lovely to see can see the graph like an event study. Yeah, I got you. Yeah, thanks.
Right. Any others? Okay, thank you very much, Omar and Arnab, and all the other participants for
thank you.
A great presentation and also discussion. So let's now turn to the next paper, Wage Inequality and Poverty Effects of Lockdown and Social Distancing in Europe. And let me invite Juan to give the presentation.
Thank you very much. Hello, everyone. Let me just share the screen. Let's see if it's working. Oh, what is going on? Can you? Okay, right now. Well, this is a joint paper with Juan César Palomino and Raquel Sebastián. During this presentation, I will show you how the COVID may potentially affect poverty and inequality across Europe. Many international institutions have already predicted large economic effects on the economy because of the pandemic. In particular, the IMF has already predicted that the decline in total GDP will be more or less 4.4% in the world this year and around 5.8% in the advanced economies. However, unfortunately, there will be many more effects. In particular, we expect that the pandemic will have a very asymmetric effect on the labor market. And as a result, we will have, or we should observe, large potential increases in poverty and inequality. Let me try to develop this argument a little bit further. Well, in principle, we have that during a pandemic, because of the lockdown and social distancing, we can work only as long as we can work from home. Therefore, the level of teleworking that we have will determine the level of our economic activity under social distancing. However, the situation is a little bit more complex because we have, in addition to the level of teleworking of our occupations, we have that some occupations are essential since, for example, you are working in the health system, then you can not stop working during the pandemic. Or if, for example, you are producing or you are in the agricultural sector, most probably you will continue working during the pandemic. On the other extreme of the situation, instead of being essential, your activity may be partially or totally closed. For example, if you are working in the hospitality sector, because under a lockdown, the government will stop you from working. Therefore, we must realize that every occupation perhaps have very different characteristics. And depending on those characteristics, you will be able to keep working or not under social distancing. Therefore, to analyze the effects on the labor market and therefore on inequality and poverty, we must do two things. The first step is to measure a teleworking index. In doing this, we have followed the methodology proposed by Dingel and Neyman, and we have calculated the teleworking index for all the occupations. Secondly, what we have to do is to propose or to classify the set of occupations into three different sets. First, essential occupations, second, closed occupations, and third, none of the previous ones. For this, we have considered the decisions made at that time by the Spanish and Italian governments. We have considered these two countries first because they were one of the first countries where the pandemic took place, and second, because of the depth of the pandemic in these two economies. So once we have the teleworking index and once we have classified all the occupations that we can deal with, we compute the so-called lockdown working ability index. This lockdown working ability index will allow us to measure how is the degree under which any worker can or any individual can work during the social distancing. And this lockdown working ability index is as follows. When the occupation is essential, his capacity of working under social distancing will be given by the essentiality score, this parameter, plus the teleworking index multiplied by 1 minus the essentiality score. However, if your occupation is closed, then the capacity of working under social distancing will be given by the teleworking index times or multiplied by 1 minus the closure score. Finally, if our occupation is neither essential nor closed, then our lockdown working ability index will be equal to the value of the teleworking index. Once we have defined this index, the one that we will use to measure the capacity that individuals have to work under social distancing, we apply this measure to Europe, to 29 European countries. And what we observe on average is that our lockdown working ability index takes a value of 0.5, while the highest value that we find is 0.6 for the Netherlands. But here, let me just focus on the map. You can observe more or less three main areas. First, Northern Western Europe, here, with the highest average lockdown working ability, then Southern Europe with a middle average of lockdown working ability index, and finally Eastern Europe, where you find the lowest average lockdown working ability. Why? Why we find these three main areas in Europe? Well, the reason lies on their averages for essentiality, for closure, and for teleworking. Let's have a look to the first panel. Well, when you look at the average essentiality that those countries have, what you find is that Central and Northern European countries basically are at the top of the distribution, while those Eastern European countries are at the lowest part. When we instead have a look to the closure, then we find very clearly that the Southern European countries are at the top of this distribution. This is explained by a basic fact. Countries like Portugal, Italy, Spain, Greece are very focused. Their productive structure is to focus on the touristic sector. And that's the reason why under a lockdown situation, many economic activities in those countries will be closed. Finally, if we have a look to the teleworking index, we find a very clear figure. As you can see here, there you find the Central and Northern European countries. Here you have Eastern European countries, and more or less in the middle, you find Southern European countries. So once we consider these three different dimensions, we arrive to the previous conclusions that we have three different areas with different average lockdown working ability indices. So let me just now apply this lockdown working ability index to measure the potential weight losses. Once we have said that this pandemic will have very asymmetric effects on the labor market, and once we have measured the lockdown working ability index during this social distancing, then let me just apply this, this index to two different scenarios. We have developed many others, but I'm going to focus only on these two. First, a lockdown of 2 months, and then the second scenario will be a lockdown of 2 months plus 6 months of partial functioning. Of course, we have assumed also in different scenarios 3 months of lockdown, 9 months of partial functioning, and instead of a closure level of 20%, we have also assumed 30% and 40%. But let me just focus on these two cases. Well, for the first case, to measure the wage loss is very simple. What we have to do is just to consider the previous salary times the duration of the lockdown, which in annual terms is 2/12, times 1 minus our capacity of working under social distancing. Then by applying this formula, we can easily compute for each individual the wage loss that individual has. In the case that we also assume a period of 6 months of partial functioning, for those individuals with a close occupation, we must include another term to the equation, which is this one. The duration of the partial functioning, which in annual terms is 6/12, in the case that we assume 6 months, then we have to multiply this number by the level of closure we are assuming, in principle 0.2. Well, when we compute those weight losses for all the 29 European countries, and we represent those wage losses with respect to the distribution of wages, what we find, as you can see in this slide, is that countries show very different patterns. However, we can isolate some of them just to make clear some ideas. For example, two extreme cases, Cyprus and Romania. For Cyprus, what we find is that clearly observation is that the lowest wage loss is experienced by those workers at the top of the wage distribution. However, for Romania, it's the opposite. Those workers with the lowest wage loss are at the lowest part of the distribution. The reason for the last result is because Romania is perhaps the European country with the largest agricultural sector. And since most of the occupations in this sector are essential, then workers in this sector will not suffer too much from the pandemic. If we have looked to other countries like Germany, France, and the UK, we find this quite general case, which is that the lower you are at the wage distribution, the higher will be the weight loss that you will suffer, and the other way around for those workers at the top of the wage distribution. The next step, once we have measured the weight losses, is that to transform these weight losses into indices of poverty and inequality. But remember, because we are focusing on the changes in poverty and inequality, we must also take into consideration the baseline or the original wage distribution. Well, when we focus on poverty, what we are going to do is a very simple analysis. We consider as our poverty line the 60% of the median wage, and we will measure the percentage of people who are below the poverty line. Once we compute this across European countries, what we find, as you can see, is that the headcount poverty index will increase a lot. We find in particular that all changes are quite sizable. They go from 7 percentage points from Denmark to 21 percentage points for Cyprus. But as you can see here, at the lowest part, we find Denmark, Germany, the Netherlands, Austria, while on the other side of the distribution of changes, we find Cyprus, Croatia, Slovakia, Greece, and Poland. Okay, so our first important result is that the headcount index will significantly increase because of the pandemic, given the asymmetric effect that the pandemic has on the labor market. When we move to the inequality side, we will apply the Gini coefficient. We all know very well this index, okay, so I'm not going to explain anything about this. We will also apply the mean logarithmic deviation, as we will see in a sec, but let me just focus now on the Gini index. Well, the changes in the Gini index are also quite sizable. As you find here, the lowest change that we find whenever we assume a 2-month lockdown plus 6-month partial closure scenario is that the Gini index will increase by around 10% in countries like Denmark, France, the Netherlands, the UK, and Germany, while it will increase around 20% for countries like Croatia, Cyprus, and Slovakia. Just to give a reference, let me recall the following. Recently, Furseri and others have found that the increase in the Gini coefficient coming from previous pandemics was around 2%. So just by comparing this 2% with the percentages that we find here, we can conclude that potentially the consequences for the inequality of the pandemic can be quite large. Finally, to finish with the presentation, I would like to show you what happens when we decompose total inequality into the between country component and the within country component. The reason for this analysis is twofold. First, we are interested in measuring which component is the main one. And the second reason is because we would like to know if the pandemic will have any consequence on the level of cohesion of Europe, because perhaps the pandemic will also increase, will be harmful for the level of cohesion in Europe. And as you can find here, apart from the fact that total inequality measured by the mean logarithmic deviation under the 2 months of lockdown scenario, or the other scenario, 2 months plus 6 months of partial functioning, we find as well that the between and the within country inequality components will also increase under the 2 scenarios we are simulating. One last word that I would like to say about this decomposition is that, as you can see here with these 2 values, 2.4 or 5.4, 5.2, the COVID pandemic will also be very harmful for the cohesion of Europe. So let me just conclude this presentation by saying that regardless of the metric, all countries will suffer significant increases in poverty and inequality, not only total inequality, but also between and within inequality. And a second thing, here in this simulation exercise, we have made homogeneous assumptions. And there are two main advantages of doing this. First, because in that manner, we can isolate the changes in inequality and poverty coming from the differences on the productive structure of the different countries in Europe or in any other part of the world. And secondly, another advantage of taking homogeneous assumptions is that we can compare our results, our potential results, with real results in the future. And by comparing both, we can evaluate the degree of effectiveness of government intervention. That's all. Thank you very much. And your questions are more than welcome. Thank you.
Great, thank you very much. So now let me invite Sun-Yun Lee to provide commentary on the paper. Sun-Yun?
Can I please share my screen?
Yes, I think that once one stops sharing, you will be able to share your screen.
I think I can. Okay, thanks a lot for inviting me to discuss this paper. And I have to say, I know this paper quite well because I was following it from early on in the pandemic, and I've also been using some of the results in some of my own research. So in a nutshell, what the paper does is, I think the most innovative part of the paper is to create something called this lockdown working ability index. And basically what this index does is jointly give you an index for each job, right? And a job is defined as a industry cross-occupation cell. And it gives you an index of that combines teleworkability, essentiality as defined by the government, and closures as defined by whether the government, how likely the government is to close down that job. So given the construction of this index, then the authors go to all the European countries for which they have micro-level labor market data and compute the outcomes of various lockdown scenarios. The benchmark scenario is a 2-month full lockdown, followed by a 2-month partial closure. Given this potential wage loss that they know across every European country within each country, then they consider the impacts on a wage inequality. And a wage inequality, since they're looking at entire Europe, they can compute wage inequality not just within each European country, but also across European countries. And the results are that inequality on average rises more in the south than in other European countries, and somewhat more in the east than in Western Europe, which is sort of expected. But they also find that between country inequality also rises, even though the within country rise is more significant. So like I already said, I think this is a really innovative, big idea paper, especially if you consider the fact that this paper was really written pretty early on. It kind of gave you a good sense of what governments were actually doing. They went out and collected all the data on what the Italian and Spanish governments were doing to give us researchers or anybody else who's interested what kind of jobs are going to be more or less severely affected. Right? As I already mentioned, I've already used this index in 2 or 3 of my own papers, which I'm going to highlight very briefly later on, because it is related to the results of this paper. And as a byproduct, for any of the audience that might be interested, I've also kind of cross-validated that this the LWA index that is constructed based on Italian and Spanish government data is actually broadly consistent with the US government, with the US guidelines as well, although the US didn't have a national lockdown, obviously. Another point that I want to make, which might not be obvious from the presentation, is that this paper involves an immense amount of data work, right? So first you have to create this lockdown index, which itself is a lot of work. Then you have to go country by country in the EU and apply that to every single country's micro level labor market data set. Right? So even doing this for a single country is actually a lot of work, if you're familiar with this kind of work, but they did it for every single European country. Right, so it's really a lot of work from which we can get a lot of insights that were summarized by Juan during his presentation. So for my comments, since the paper is already published and the pandemic has kind of progressed beyond the early stages, I'm going to focus more on possible application and extensions rather than a critique on the paper itself. So the first thing is, I mean, the LWA index, as I said, I think is the most innovative part of the paper. This is constructed as whether, like, how likely a job is going to be affected during a lockdown. And a job in this context is defined as I already mentioned, as a cell within an industry, a particular occupation within a particular industry. Right? But the telework index that they use in conjunction with the LWA index is based on the ONET. And the ONET, as you might know, is based only on occupation, right? So there's no variation across industries for the telework component. Right? So maybe you could use time use surveys or other data sources that might be available in Europe to create some industry level variation also for the telework component that's going to be plugged into the LWA index. Right? So that's just a small comment on how you construct the index. Now turning to how you actually run the scenarios. So during the lockdown period, you consider the essentiality of jobs, right? So when the government promulgates a lockdown, it kind of leaves open the essential jobs. But then during after the 2-month initial lockdown period, you're only considering partial closures. This, I guess, it might be a byproduct of the paper having been written early, right? But even during the easing of the lockdowns or the partial closures, essentiality was still taken into account, right? So maybe you could also now run another scenario where you also include essentiality in the past the full lockdown of 2 months. This is mentioned in the paper and the authors are well aware, but all the economic losses or wage losses in this paper are only coming from lockdown, right? But as we know, lockdown, the only economic losses that come from COVID are not coming from lockdown, right? So even in countries or US states where there was no lockdown, there's been a large response, right? And even in those states and countries where there was a lockdown, there was already a large response prior to implementation of a lockdown. That is to say that many jobs are affected even without the implementation of non-pharmaceutical interventions. And kind of related to that is it's going to depend on how exposed a job is to the fear of COVID. So when you think about how susceptible is a job to COVID, it's not just about how susceptible is a job to a lockdown, it's also just voluntarily how likely is it that the worker in a particular job might not want to go to work, or even if they want to work, they're not going to be able to because demand has just shrunk by too much. So if you have a good idea of that, then you can also evaluate how good were government selections of essential jobs and closures, right? So it might be that there was sufficient demand and a particular job was not very dangerous, but the government just shut it down, right? Which was not considered when the government decided to shut that job down. And so these kind of things are now things that we could evaluate since the pandemic has progressed by almost a year. And the last point I want to make, which is also a byproduct of the pandemic having progressed, and there were some questions already in the Q&A with those, is since we know which jobs had a high lockdown index, now we can also ex post evaluate whether those jobs were well subsidized. So most countries have some sort of subsidy scheme against COVID-19. And now we can see, like, well, if the government shut down this job, did it also at least offer some kind of carrot in the form of a subsidy? Right? So overall, I'm just saying this paper was written pretty early on, but now we are in a place where we can use this lockdown index to evaluate how good these indexes were. Right? So one example is kind of what I did for the US. So what I'm plotting here on the right-hand axis is the wage loss. So the wage loss is computed in a similar way.
Can you try to conclude in 1 minute?
I'm going to conclude in 10 seconds, sorry. Right? And the y-axis is just how exposed a job is. And the red dots are the LWA index, the jobs that are locked down according to the LWA index. And the blue dots is what is optimal, right? So we can do this kind of optimality exercise ex post. Right? So to summarize, I just want to say that this is a really great paper. The LWA index idea is very innovative. And now we can use this LWA index to evaluate how good government dealt with the COVID crisis. Thanks.
Great, thank you. So again, let me just read a few of the questions in the chat box, so one can try to respond if you want to. As Sun Yun has already alluded to, some of the question is related to have you also explored or incorporated that government wage support by governments? The second question is, would you be able to separately identify lost wages, furloughs, versus layoff and firm closure? I mean, the context of this is on this, and for the second group that is laid off, the re-enter into the job market will be much more difficult than just lost wages. And then finally, it's a question specifically about over what horizon, I think he meant time horizon, do you expect the poverty impact to be materialized? And the question feels that the data on Cyprus seems that the huge increase in poverty incidence is not implying that it has happened yet. It has completed that cycle. Thanks.
Thank you very much for all your comments. Well, first of all, I would like to say a few things about the databases. Of course, the problem with Europe is that they are less disaggregated than the ONET database. So for that reason, we have that problem between distribution versus occupations between the ONET and the European databases. But being more general in my answers, I would say that the main objective of this paper was just to measure how different are our economies from the productive structure perspective, just to suffer from the pandemic. In other words, even if the pandemic is the same for all the countries, and even if all the governments apply the same measures, just because they have different productive structures, they will suffer or they will have different consequences in terms of inequality and poverty. So just to measure those potential results or effects, that was the main objective of our investigation. For sure, we would like to know which has been the reactions by the governments, the effects of those subsidies and those wage supports by the governments, but we have to deal with the data, and we haven't worked with that yet. We hope to measure those results and to compare what has already happened with the potential results that we have estimated in our previous paper. And just a final word about Cyprus and the horizon. Do you expect this poverty impact to be materialized? Well, hopefully all the measures that have been implemented by the governments all around the world will reduce a lot the variation in inequality and poverty, but still the problem is there, which is that without doing nothing, just because the structure system of the economies is very different, and the pandemic has a very asymmetric effect on the labor market, the consequences for inequality and above all for poverty can be quite large. That is perhaps, if you let me to summarize the main result of the paper, the main conclusion. Apart from that, for sure, in the future, we have to check these numbers with those coming from reality, coming from the real response of those countries. But in any case, thank you for your suggestions and questions.
Great. Again, David.
Okay, thanks for the very interesting paper. We're all in this literature waiting for the actual data to come in. I guess just one thought is that, you know, in the US for sure, but I know a number of people in Europe too, who are particularly in the high wage sector, had their jobs locked down, but they didn't lose much in the way of salary. Example would be public school teachers. You know, schools are closed. There's certainly some work, you know, it's not zero, but it's a lot lower. But in many cases, the salaries weren't removed at all. My guess is that type of thing affected much more the high wage people than the low wage people. It'd be nice to see the actual data, but if that were true, what I'm saying, then the wage inequality effects would be even bigger than what you show.
It could be the case.
Excellent comment. Any other comments?
Can I make
Okay,
one
good.
last
Yes,
comment?
yes, Tanyan, go ahead.
I didn't want to belabor on it, but the paper, when you present it, you're kind of dividing Europe into regions and making a contrast. But that seemed a little bit unnecessary to me, because country by country seems to be unique enough. Like when you talked about Eastern Europe, for example, but like Romania, where I am right now, is very different to Hungary. So maybe it's better to kind of highlight specific countries rather than like lump them by region together.
Okay.
All
Thank
right,
you.
great. Thank you very much. And let's move on to the next paper. And let me invite Carolina to present their paper on the impact of COVID-19 on household economic dynamics in Kenya, Burkina Faso, DRC, and Nigeria. Carolina, please.
Thank you. Let me share my screen. Okay. I think I need to swap. Okay, can you all see my screen?
Yes.
Okay, great. So first, thank you for letting me present today. The title of my presentation is The Economic Impact of COVID-19 in Sub-Saharan Africa by presenting evidence from 4 countries. This is a joint work with Elizabeth Gamerson, Phil Anglewick, Blake Zachary, George Kiela, and Scott Ratloff. And I'm gonna start by providing some background information. So when COVID-19 hit the world early last year, many people hypothesized that African countries were going to be heavily hit by the pandemic, mainly because African countries have a weaker health infrastructure and also a comparatively large immunocompromised population due to endemic challenges such as HIV, malaria, and malnutrition. However, as we can see on this map that is plotting the number of deaths per 1 million population, where darker brown indicates a higher count of deaths, we can see that the African continent is actually colored in a light brown tone. And the region that accounted for the larger counts of deaths was the Americas, that they registered approximately close to 900,000 deaths, while the African continent registered only 43,000 deaths throughout 2020. Partially, this can be explained by the fact that African countries do not have a strong civil registration system. However, the difference is very large to attribute it solely to civil registration systems. We also know that African countries have a young population, and they also have a unique resilience to a pandemic shock based on their prior experiences with HIV and the Ebola outbreaks they've had. So they also have infrastructure and procedures in place that allows them to respond to pandemic shocks. And more importantly, they also have a population that has experience altering their daily behavior to respond to shocks. As we all know, and as we've been discussing throughout the presentations today, the main intervention that many governments took as a way of controlling the spread of COVID-19 was the implementation of lockdowns that limited individuals' mobility to leave their houses. And for people that work every day, that need to leave their houses, they were not able to do it. And as we know that Africa has a large informal sector. So based on that, the World Food Programme predicted that by the end of 2020, 43 million Africans may be pushed into food insecurity by the end of 2020, where we understand food insecurity when an individual is not able to eat for more than 24 hours. Also, evidence from high and middle income countries from last year have shown us that the economic consequences of COVID-19 have been disproportionately impacting low-wage manual workers, women, and the poor. So based on that evidence, also many people hypothesized that the African countries were going to have more severe consequences because mainly they have widespread poverty and there is a limited social protection system provided by the government. And as I mentioned earlier, they also have large informal sectors that make people particularly vulnerable to lockdown measures. So based on that background information and motivation, in this study, what we intend to measure is the extent of the economic impact of COVID-19 in 4 countries in sub-Saharan Africa. We are particularly focusing on measuring household income loss, food insecurity, and access to health services. And we're also interested in identifying what are the socio-demographic correlates of this outcome. Our analytical approach is very simple to measure the differences in this outcome, in which we would need to recover treatment effects at the individual level that would compare the individual's outcome in both states of the world. However, we can only observe the state of the world with COVID-19. To recover this delta O, or this change in outcomes, the approach that we followed was to directly ask individuals for their subjective value of delta. We are aware that by following this approach, we are taking the key assumption that individuals have well-formed expectations of their outcomes in both states of the world. However, because of our three outcomes of interest influence greatly individuals' everyday living, we believe that this is a reasonable assumption, because we believe that individuals would be aware if their household has lost some sort of income, or if a member in their household was not able to eat for more than 24 hours, or if an individual was not able to access health services when in need. The innovation of this study relies on the richness of our data. In order to collect this, the difference in the change in the outcome in our three outcomes of interest, we leverage on an ongoing project that we've been conducted in countries across sub-Saharan Africa, that is Performance Monitoring for Action, or PMA. PMA is a longitudinal study that follows women of reproductive age and also interviews health facilities. The goal of PMA is to guide family planning programs. In 2019, prior to 2019, PMA was designed as a cross-sectional study, but in 2019, it shifted as a longitudinal study. The first wave of data was collected between October 2019 and January 2020 through an in-person interview. This first wave of data was collected in Burkina Faso and Kenya, in Kinshasa, DRC, and in Lagos, Nigeria. The original design from PMA was to collect a phone follow-up interview 1 year later. However, last year when COVID-19 hit, we decided to shift the design of PMA and implement a COVID-19 specific survey as a follow-up to the women that participated in the phase 1 interview 6 months later. Our COVID-19 survey was collected between June and July of 2020 by a phone interview, and it consisted of 9 different modules, collected different information related to COVID-19. The one that I'm presenting today comes from the socioeconomic module. So as I said earlier, our information comes from interviewing women, and our 3 outcomes of interest are household income loss, food insecurity, and access to health services. So to proxy household income loss, women were asked to indicate if their household had experienced some sort of income loss since COVID-19 restrictions began in their country. They could indicate if their household experienced none, complete, or partial. To measure food insecurity, women were asked to indicate if she or any member in her household have gone through an entire day and night without eating anything because there was not enough food since COVID-19 restrictions began. And finally, to measure access to health services, women were asked if she needed to visit a health facility since the COVID-19 restrictions began, and if so, if she was successfully able to attend such services. Our final sample consisted of approximately 1,200 women distributed across our 4 locations. Something that it's important to mention is that in order to receive a follow-up call, women need to provide a contact number at the in-person interview. So we need to control for the fact that not everyone owns or can access a telephone. And to do that, we implemented inverse probability weights. And we also implement IPWs for the response rate for the women that were able to provide a phone number to reach out. Our response rate ranged from 75% in Burkina Faso to 94% in Kenya. In our estimation to identify the characteristics that are associated with each of our outcomes, we implemented a multinomial logistic regression for household income loss. And for food insecurity and access to health services, we implemented a logistic regression. All of our regression include geography fixed effects, mainly because our national samples of Kenya and Burkina Faso, they're both representative at the national level, and they're also representative for urban and rural areas, and they include subnational level data. All of our models include individual and household level characteristics, such as marital status, parity, age of the women, education of the women, the number of members that live in the household wealth, which is proxied by a principal component analysis, and the work status of the women. All of these characteristics are taken from the baseline survey, not the follow-up. We implemented different approaches. First, we implemented our regressions at the country level. Then we did a pooled analysis with geography fixed effects. And then we also did a pooled analysis, stratify only for urban areas and for rural areas. What I'm presenting today is the results from the pooled analysis. And now I'll show you some of the results. So these are the straightforward results from our survey, from the pooled analysis. What is shocking here is to see that across these 4 countries, we observed that there is a large percentage of women that indicated that their household suffered some sort of income loss. Only 13% indicated they did not have an income loss since COVID-19 restrictions began. It is also shocking to observe that almost 1/3 of the women indicated that at least one member in her household was not able to eat for more than 24 hours. As for receiving healthcare services, we see that this was not such a large percentage of women that were not able to access. 92% of the women said that they were able to access healthcare services when they needed them. I'll now present the characteristics that we find to be significantly associated with each of our outcomes. For now, I'm just showing the results from experiencing complete income loss. And what you see in this graph are the relative risk ratios from the multinomial logistic regression. We find that there is a linear relationship with parity. And we find that women that have more than 4 children had more than 3 times the probability of experiencing complete household income loss compared to women without children. We also find that women of older ages are more likely to experience some complete income loss than women of younger ages, and that the number of members in the household are also significantly associated. The results here on this slide are the same as in the prior one, but these are adding the coefficients from the stratified models, where the orange dots are from the urban models and the purple ones from the rural models. We find that our results hold for this stratification, but that parity has a lower magnitude in urban areas than in rural areas. These are the characteristics associated with experiencing some sort of food insecurity. And similar to experiencing household income loss, we find that parity is significantly associated, where women that have more than 4 children have more than 2 times the probability of experiencing food insecurity compared to women without children. And we also find that education is significantly associated with experiencing food insecurity, where women that are more educated have a lower probability of experiencing food insecurity than women with no education. As with the other results, these are the results for the urban and rural stratification. We find that for parity and education, our results hold, and that parity seems to matter more in urban areas than in rural areas, and that education matters more in rural areas than in urban areas. These are the results from our model for accessing health services. And in this model, we have the same covariates as in the other 2 specifications, but we also added food insecurity and household income loss as potential predictors of accessing health services. And we find that the women that indicated that their household had experienced food insecurity were less likely to being able to access to health services than women that did not experience food insecurity in their household. These are the results for the urban and rural stratification, and we find that food insecurity holds. Something I should mention is that when we look at our descriptive statistics stratified by urban and rural areas, we find that there are significant differences in experiencing household income loss, where urban households have there is a larger proportion of women indicated their household experience household income loss in urban areas than in rural areas. We find a similar result for accessing health services, and we don't find that for food insecurity. It's also interesting that I should mention that we were hypothesizing that we were going to find a wealth gradient across our outcomes of interest, but we did not find a wealth gradient, which was something that I think it's worth exploring further. So to conclude, we find that households suffered substantial income loss during the initial period of COVID-19 restrictions. As we've shown, only 13% of the households indicated they did not suffer some sort of income loss. We find that it's interesting that food insecurity is an event that is not only affecting households from the poorest wealth distribution, rather it is affecting everyone. But poor households are at a greater risk of being food insecure. What is interesting in the correlates to each of our outcomes is that we find that women with children have a higher probability of being food insecure and also experiencing some sort of income loss. And we also find that education matters as for experiencing food insecurity. As next steps, we intend to include community measures to explore community measures as mitigating factors of our outcomes, mainly based on the African context, where the community is important and can help as a resilience factor to overcome some of the shocks that are produced by these lockdown measures. Currently, we're conducting a 6-month follow-up because that was the original PMA design, and we're implementing our COVID survey as well as the standard PMA survey. And we're also expanding the analysis to the other PMA countries that are India, Uganda, Niger, and Cote d'Ivoire. And you can find more information on our website about our data. Thank you.
Great, thank you very much. So can I now invite Enrica to provide commentary? You're muted. Enrica, you're still muted. Enrica, you're muted.
Yes,
okay.
I'm trying to share my screen.
Right.
Okay, perfect. Okay, Carolina did a great job providing the background information. So for the sake of brevity, I'll skip that. And I'll quickly, as usual, I'll quickly summarize the paper to fix the because it helps me with the discussion. Carolina and their co-author, they try to understand what's the economic impact of, I'm not able to move my, sorry, I'm not seem to be able to move my slide. Yeah. Oh, excellent. Carolina and their co-author they try to understand what's the economic impact of the pandemic on households in sub-Saharan Africa. And specifically, they focus on 3 outcomes: household income loss, food insecurity, and healthcare access, and how these outcomes correlate with socioeconomic characteristics at the individual level. To do so, they can rely on novel panel data collected by this performance monitoring for action project in 4 sub-Saharan countries that Carolina just mentioned: Kenya, Burkina Faso, and regional data for Lagos in Nigeria and Kinshasa in the Democratic Republic of Congo. And the nice thing of the data is that they have a baseline survey that was conducted right before the pandemic spread to Africa. And then they have a follow-up that they conducted during the, after restrictions were imposed in these countries. The analytical approach they follow is the following: to clearly they are interested in the causal effect of the shock on the outcomes, And to do so, they would need to observe these outcomes in both states of the world, the state of the world with the COVID and the state of the world where there is no COVID. And obviously they can only observe the situation in which we had the COVID the realization with the COVID. So their idea is to ask respondents for their subjective evaluation of outcomes in both states of the world. And they proceeded to measure, for instance, household income loss by asking respondents whether they had experienced some income loss with respect to the onset of the restrictions. And they do something similar with food insecurity. They ask whether whether any person in the household has gone 24 hours without eating during the restriction because they had no food in the house. And healthcare, as far as healthcare access is concerned, they ask first whether they needed access to some care services, and if so, whether they have been successful in getting the care that they needed. And empirically, then they proceeded to investigate the correlation between the prevalence of each of these outcomes and the socioeconomic, individual, and household characteristics measured at the baseline. And specifically for the income loss, they ran a multinomial logistic regression, which they consider 3 different alternatives: partial income loss, complete income loss at the household level, and they compare them with no household income loss. And for the other outcomes, they they produce logistic regressions. Okay. And to summarize the main findings, in all the 4 countries, they find high prevalence and levels of income loss. As Caterina was mentioning, basically in 9 out of 10 households, there has been some income loss. And then they find also a large increase in food insecurity, and this actually for 1 out of 3 households. And this is the only outcome that shows a wealth gradient in all countries. Okay. They also find heterogeneity in access to healthcare, but as far as except for the Democratic Republic of Congo, it seems like the other countries women in the other countries are doing fairly well. At least 9 out of 10 are able to get the access that they need. Okay. Also, what they find is that the economic shock, both as far as income loss and food insecurity, is experienced across the socioeconomic spectrum. And the results make sense. For instance, they find that these adverse outcomes are most likely have taken place for the households that are more at risk, more in these households than in the wealthier tertile, for instance, or in the households where there are fewer children or no children. My comments, I only have a few comments, and the main comment basically concerns the validity of the approach. To be plausible, the analytical approach that they follow requires 2 conditions to be satisfied. One, that the respondents have information about outcomes in both states of the world, both the one in which we had the COVID realization and in the counterfactual state of the world. And and 2, that there is no systematic bias in the reporting of the data. Regarding the first condition, they acknowledge that we can observe only the COVID state of the world. I'm actually concerned that there is no real counterfactual of what would have happened in the absence of COVID. They do they do ask respondents about income loss since the onset of COVID, and also as far as food insecurity during the COVID restrictions. However, I think that these 2, for instance, both income decline or food insecurity, they could have happened also in the absence of COVID. And there is no way of, there are 2 idiosyncratic events where cause and effect, they are likely to be difficult to disentangle, I think. I think this is the major issue with these type of approaches. Okay. Also, Carolina, I only got a preliminary draft. She addresses partly the issue on these slides. I'm actually concerned also with the basically systematic selection bias in the sample, because the interview mode changed from baseline that was in person to the follow-up interview that was phone-based. And I noticed that there has been serious attrition in 6 months, and the follow-up samples are, they go from 50% to 66% of the baseline. Carolina mentioned, I don't think it was mentioned in the paper, in the draft that I got, but so clearly if you want to answer a phone interview, if you need to answer a phone interview, you need to have a phone, okay? And I'm understanding today from the presentation that they are kind of taking this into account with the weights. But in general, this would be a concern with approach. Okay. Moving on to the econometrics, they study income loss using a multinomial logistic regression. And they distinguish these through 3 categories: partial income loss, complete income loss, and no income loss at all. It seems to me that though that there is some kind of ranking between these 3 categories. And so I think there might be problems with the independence of irrelevant alternatives hypothesis that you need for the to apply the multinomial logic. And I would suggest to try out at least ordered probability model or some kind of ordered logic. They mention using weights in the regressions. I guess I would like to see weights in the descriptive statistics. And maybe as far as the regressions is concerned, maybe I would suggest running both weighted regressions and unweighted regressions. I myself prefer the unweighted ones, but maybe run an Austin stratification test for econometricians, and hopefully you get similar results. And
so, Rika, I'm sorry, can you wrap up soon?
Yes, I have 2 slides. Okay, thanks. And
just have a minute.
Okay, I will do it. Okay, so some final considerations while I was reading this. I mean, the paper is really fascinating. And since the respondents are women, I mean, one thing that came up to my mind is that there is lots of evidence now in the Western countries that this pandemic is affecting disproportionately women more than men. Okay, especially in Western countries, there are lots of nice papers by one of the co-authors of the next paper, together with Matthias Dobke in the MBR, and also there is a special issue of the Review of Economics of the Household that actually is forthcoming and contains also some paper on Africa, on different countries. And these effects on women are actually likely to be persistent because of these high returns of experience in the labor market. And I would encourage Carolina, you know, in the future to explore the gender inequality dimension of the pandemic. And as far as these specific papers is concerned, I'm wondering whether they have, in the case of partnered women, whether they have information on both partners. And I was wondering, I think it would be interesting to know when you have partial income loss, whether one of the 2 partners lost the income and whether whether they can rely on the other partner for economic help, And overall, I think it's really a nice paper. It's very preliminary, but it's very nice, and it addresses an important research questions we still don't know much about, and I'm very much looking forward to the revision and final revision. I'm done. I have some minor comments that I will send to.
Okay, great. Thank you very much. In the interest of time, just quickly summarize the other 2 questions. One is just a suggestion that income inequality, food insecurity, and access to healthcare perhaps can be modeled as continuous variable, as a suggestion from the audience. The other one is to ask if you have looked at whether rural households are able to cushion the income loss effects on food security by directly farming. So Carolina, do you want to just quickly respond to Enrica's comments?
Yes. So Enrica, thanks a lot for your comments, and I would be happy to, if you could share your slides, that would be great. You are absolutely right that a key assumption of our entire analysis relies on the individuals, women, being able to provide their perception of the state of the world with COVID and without COVID, and that's a strong assumption. Yeah, and it might be that it's a strong assumption, and we're aware of it. However, we believe that these three outcomes are like affect people's everyday living, so might be something there. Yeah, we don't have a counterfactual, so we do rely on that assumption. As for the attrition rates and the phone ownership, yes, we were aware that phone ownership was a big thing on our survey, not just for COVID, but for the PMA study overall, because it was originally designed to have a phone call follow-up, not an in-person, because it reduces the costs of the survey. So we do implement the inverse probability weight first. We wait for the probability of being able to give a phone number. It's not just owning them, but they could also give you a phone number of their brothers, sisters, or someone where you can reach the women. So we do that. I really like your suggestions about the ordered probit. I think that's a great suggestion for the household income outcome, because you're right, it does follow one order, experiencing partial or complete. Also a great suggestion of just presenting the unweighted results. Maybe they should be weighted for phone ownership. I don't know, something to think about, because that's like something that really affects the data. As for the household lost, yes, so we only ask about the overall household income loss, but because we're implementing the follow-up currently for the 1-year follow-up of the original PMA design, so we can think about asking if there is a difference between men or women, but the questionnaire is only for women, but they could potentially answer what their partner has experienced. As for the other questions from the audience, so yeah, the person that asked about the experiencing food insecurity is absolutely right. This is not the only metric to ask. There are other ways of measuring food insecurity, but we chose this one because it's the most severe form of food insecurity of how it is defined. We could measure it differently, but we chose to stay with this one. As for the phone interviews, so the phone follow-up for the COVID-19 survey was not an extensive survey. It was only for COVID-19 surveys. It did not contain any information about the other PMA questionnaire. So it wasn't a long survey, but we're going to conduct now the 1-year follow-up, which is a longer survey, and we'll see what that happens with it.
Great. Okay, well, thank you very much. And let's turn to the last paper, last but not least, on how should policy responses to COVID pandemic differ in the developing world. And let me invite him to do the presentation.
Yep, let me quickly enlarge this. Can you see my screen, by the way?
Yes.
Okay. Okay. Thank you very much for giving us a chance to present our paper in this session. This is a joint work with Titan Malone, David Lagakos, and Mitch Van Buren. So befitting the title, this paper is about how should the policy responses to the COVID-19 pandemic be different in developing countries. We tried to address this question by doing a macroeconomic analysis using an incomplete market model with the epidemiology block, with the disease spreading endogenously in the model. We classify the developing country as the countries in the bottom quartile of the world income distribution, and advanced economies as the countries at the top quartile of the world income distribution, and calibrate the economy accordingly. So the first draft of this paper was written in May, and by that time, COVID-19 was rampaging through most of the advanced economies, and also marching down its way to the developing countries. So the natural question of this paper came out because policymakers in developing countries were being asked to take action promptly, but they were not sure about whether they can copy the containment policy done already in the advanced economy, such as large amount of physical transfer to the populace, prolonged period of lockdown, or etc. So we thought that it was important, and it's going to be important in the future of any event of infectious disease outbreak, to understand the key differences between advanced and developing countries, and understand the importance of each channel in terms of the effectiveness of the containment policies. So in this paper, we focus on five main differences between advanced and developing countries. Most of them already addressed in Carolina's presentation earlier. So I'm just gonna go fast here. The first one is younger population, which can be favorable to developing countries, especially for the COVID-19. The second one is less fiscal capacity, which can be an obstacle for the developing countries' government because they cannot make as much as transfer to the populace as in advanced economies. Third one is a large informal sector, which is already also mentioned in Carolina's presentation, which can actually be an obstacle in enforcing the lockdown to the entire nation because it's hard to enforce a lockdown to the unregistered firms, small businesses, and small size farming. The fourth one is the less healthcare capacity, obviously, and this can also be an obstacle for the developing countries to control the pandemic. The fifth one, which is not mentioned in the previous presentation, is the larger household size and intergenerational cohabitation. So this reflects that more common intergenerational cohabitation living arrangement in developing countries. So the first four things are rather straightforward to capture with the standard macroeconomic model, but the last one is relatively new. So in order to capture that, we borrow a concept from epidemiology literature. And specifically, we use the concept called contact matrices, which is a measure that summarizes the patterns of social context that people make in everyday life. So this is an example of contact matrices. Contact matrices are also location. A home contact matrix as an example. So this summarizes the patterns of social contact at home. So the left-hand side is the advanced economy one. The right-hand side is the developing economy one. And the x-axis is the age of the individual. And the y-axis is the age of the people that this individual is making contacts. So for example, if you're around age 20 at home, the person that you make the contacts most frequently is also around age 20, which is most likely to be your spouse. If you're around age 60, you're still making the most amount of your contacts with someone at your similar age, but you're not making as many contacts with kids because it's not very common in the advanced economy to live with your grandchildren. The pattern is very distinct in developing countries. The diagonal element is still very distinct, but as you can see in these dark regions here, it's more common for developing countries that old individuals make more contacts with kids and their grandkids. So 60-year-old individual make more contacts compared to advanced economy with someone around age 10 or below. Okay. So here's the brief summary of our finding using our model. So first finding is that blanket lockdown, which is a lockdown that applies to the general populace, is much less effective in developing country compared to advanced economy. It turns out that blanket lockdown saves around 1/3 as many lives per GDP lost in developing countries. We also entertained two specific containment policy. So the first one is age-dependent lockdown, and it turns out to be more effective in developing countries. And the last thing we consider is the school closure. And our result tells us that closing schools in developing country can be a potent way of saving, especially older lives. So for the interest of time, I'm just gonna talk about the non-technical part of the model. So this is the summary of the model in a nutshell. The model can be summarized as a standard two-sector heterogeneous agent model with the epidemiology block added on top of it. So we have four major pillars of the model. The first one is epidemiology block. We have a SICR, susceptible, infected, critical, and recovered dynamics with the age heterogeneity as introduced in the Global et al. Paper. So we have three age groups. The first one is children, the second one is young adults, and the old population. And in the model, virus spreads through the context at 4 different locations. As I said, these contact matrices can be location specific. So we have 4 different locations. We have home, workplace, school, and other locations. The other 3 blocks are rather standard. So households, they face uninsured idiosyncratic labor income risk and health risks, just like in a Yagari type model. They also accumulate asset endogenously and they face credit constraint. We have 2 sectors, formal sector and informal sector. Formal sector represents skilled production. Informal sector represents unskilled production, such as like street vendor, small size farming, unregistered small size firm, etc. And it's also assumed to be difficult to enforce the lockdown for the government or even collect taxes. Lastly, there's a government which imposes containment policies, and they collect taxes and make transfer, but with the limited fiscal capacity. So here's a diagram how individual health status make transition within the model. So a susceptible individual can become infected with this probability, infection probability pi I, and the infection probability depends on the age of the individual and whether the individual is working in the formal sector or in the informal sector. An infected individual can either be recovered and being critical, and that also depends on the age of the individual, and the critical condition individual can be either recovered or die, and that also depends on the age of the individual and whether the hospital overuse is happening. So we model the hospital capacity as the maximum ICU capacity per capita, and we assign the probability of receiving an ICU bed when the individual is in the critical condition, and when the number of people in the critical condition in the economy is greater than the ICU capacity of the economy, then there's a possibility that some individual not assigned to an ICU bed. And in such case, we ramp up the probability of death by this kappa amount. So this kappa parameter governs the impact of hospital overuse on the fatality rate. And the initial infection probability is a combination of the baseline infection transmission rate and the number of contacts that each individual is making to other age groups, and the fraction of individuals who are infected within each age group. So this will determine the infection rate within the model. Other parts of the model, so these are standard heterogeneous agent model. We have two sectors, as I mentioned, and children's are all just introduced as a pure disease vector, so they don't produce or they don't consume. And only young adults and old individuals are endowed with the vector of permanent productivities in formal and informal sector. And based on those productivity draw, individuals choose sector in each period, and they also face idiosyncratic productivity shock, just as in the Inequality type model. It's a model of COVID, so we have health shock and lockdown. So health shock is just a COVID shock. So being infected drops all productivity by some fraction of eta, and being in the critical condition drops all productivity to 0 until he or she gets recovered. So this is the condition that you have to go to the hospital and hopefully get assigned the ICU bed. Lockdown is imposed by the government. Lockdown does two things. First, it lowers the productivity of individual. So in reality, lockdown is a restriction against working. And one way to model that is just model it as a negative productivity shock. So individuals' productivity in the former sector goes down to lambda. So lambda can be understood as a lockdown intensity parameter. It also lowers the number of contacts at workplace and other location by 1 minus lambda fraction. So this is a direct mechanism how lockdown reduces or mitigates the infection spread by reducing the number of contacts that each individual is making. Lockdown affects formal and informal sector, but not equally. So informal sector contacts also is affected by the lockdown, but with the lesser degree by a factor of 18% smaller degree compared to formal sector. So this reflects the informal sector's lower compliance to the lockdown. So the key trade-off individuals is facing under lockdown is the occupational choice, the sectoral choice trade-off. So under lockdown, working the formal sector is safer, always safer, because the lower infection probability because of the reduced amount of contacts. So this will generate inflow of workers into the formal sector and result in better compliance to lockdown. And especially there's going to be higher incentive for old individuals to stay in the formal sector because COVID-19 is especially fatal for the old population. On the other hand, working in the formal sector results in income losses due to reduced productivity, and this might generate outflow of workers from the formal sector, and that might result in weaker compliance to lockdown. So this is where the better fiscal capacity of advanced economy can kick in, because better fiscal capacity and larger amount of transfer can minimize the income loss and make the people stick to the formal sector jobs. Okay, so for the quantitative analysis, with this model, we solve for the stationary distribution of the model, and we calibrate the model to the two versions, one for the advanced economy and one for developing economy. So this is taken as an average of the top countries in the top world income, top quartile of the world income distribution, and this is the bottom of the world income distribution. We introduced pandemic as an MIT shock. No one else has ever saw it coming, so this is actually realistic. and everyone has the perfect information once the shock hits the economy. We solve for the full transition path in 2 versions of the economy under various containment policies and compare the result. Okay, I'm going to skip through this calibration table and just go directly to the result. So this is the model fit. The blue line is the data, red line is the model. So what we do here is to feed in the actual lockdown happened in the data and make the model to predict the period by period death in the United States. So this is one for the United States. We do the same thing for Mexico, and the pattern is pretty distinct compared to the United States because we feed in the different scenarios of lockdown, which actually happened in Mexico. So with very parsimonious structure that differentiate advanced economy and middle income country, which is like Mexico here, we're capturing the differential patterns observed in data pretty well. We're not capturing this like recent spike in infection in November and December. We believe that's like because of the external factors not included in the model, such as like Thanksgiving holiday, election in the United States, etc. So with the calibrated model at hand, we entertain 2 options of containment policy. The first one is age-dependent lockdown, or AKA shielding the elderly. So this is introduced as a lockdown of locking down only the old population and making transfer only to the old population too. This is motivated by the highly heterogeneous effect of the disease itself by age. So it might be actually more effective to just protect the elderly people, older population. The second option we entertain is the delaying the opening of the school or school closure. This was motivated by the more common intergenerational cohabitation living arrangement in developing country, which actually suggests that children can actually be a very important disease vector. So even though workplaces are under lockdown, children can go to school and bring the disease to the home, and within household infection can be crucial in spreading the disease in developing countries. So in the model, we just eliminate the social contact at schools. No one's going to school, teachers and students are not going to school. And we run the simulation for these 2 containment policies. So here's the main table. So we simulate the combination of blanket lockdown, age-dependent lockdown, and school closure. And we fix the lockdown period for 70 weeks. And these are the number that we call like bang for the buck measure. These are the life saved per 100,000 people for every percentage point of GDP lost. So the higher the number is, each cells of containment policy is more cost effective in saving lives. So first takeaway here is age-dependent lockdown. Age-dependent lockdown is always, not always, but in general, better than blanket lockdown in both advanced economy and developing economy. If you compare these 2 columns within this advanced and developing economy panel, then age-dependent lockdown's number is always higher in compared to blanket lockdown in the advanced economy, regardless of schools closed or open. So this number, sorry, my mouse is too sensitive. These 2 numbers are higher than these 2 numbers. For a developing country, when schools are closed, age-dependent lockdown is more effective than blanket lockdown, but not so much. It's actually a little bit worse when schools are open. This leads to the natural second point about the school closure. So if you compare these 2 rows, when schools are closed and when schools are open, you can see that school closure is always better in terms of saving lives than school opening for every combination. But the degree how much school closure is better is different across advanced economy and developing economy. You can see that school closure with blanket lockdown or age-dependent lockdown is about 1.5 times better in advanced economy, but it's almost like 3 times as good as the same policy under school opening scenario in developing countries. This indicates that opening school can significantly mitigate the gains of age-dependent lockdown or any lockdown because of the intergenerational cohabitation and simply more context happening at school because of the larger school class size in developing countries. Okay, let me conclude here. So we did macroeconomic analysis about how pandemic responses should be different in developing country. 2 takeaway was school closing and shielding the elderly was more effective, and blanket lockdown itself is less effective in developing countries. And of course, although we're seeing some hope in ending this pandemic in this year, there are we're waiting for the more data to come in. So we haven't included like a lot of like other features of the disease itself, like oral child transmission, blood type, and comorbidities. They're not considered in our model. And in terms of modeling, now everyone knows their health status precisely, and we're thinking about including imperfect information setting or like open economy issue, and of course inequality, because we're using heterogeneous agent model, but we're still waiting for more precise data to come in. Thank you very much. I a little bit ran out of time. Yeah.
Thanks. So let me turn to Edwin to provide his commentary. Edwin, yeah, okay.
Yes, thank you. Let me just share my screen. Great. So thank you for the opportunity to give comments to this paper by Alan and presented by Minki. So I'm just going to give a couple of comments. One is to basically start with what the paper talks about in a nutshell. So the authors use a macroeconomic model to assess the impact of COVID-19 on containment policies in high-income and low-income country. One of the great things about the model is that it appreciates the differences in key characteristics across these countries that has already been explained in the presentation. So issues around, for instance, demographics or age structure, fiscal constraints, informality, health system capacity, and contact mixing. The key takeaways or findings of the paper is one, that blanket long-term lockdowns are less effective in low and middle income countries compared to high income countries, and that targeted policies such as, for instance, age shielding and closure of schools are more effective in LMICs compared to, rather more effective in LMICs compared to high-income countries. And so what the paper essentially recommends is that perhaps low and middle-income countries should focus more on targeted policies as opposed to blanket long-term lockdowns. And I guess this paper is in many ways linked to the other papers that we've had today, especially papers around impact of COVID and COVID restrictions on income inequality and impact on lockdowns on wage inequality and other aspects of socioeconomic dynamics within households. The paper contributes to an emerging literature on the macroeconomics of the COVID-19 pandemic. And, so this is quite timely in the sense that there has been concern. There is concern that economic evidence is not, has not been used to the extent that it should be used to inform policy responses for COVID, to inform choices by countries to, on what policies they should use to implement, or rather to respond to the COVID pandemic. The paper illustrates the value of economic analysis in informing COVID responses across countries, and it also adds to the evidence on the debates and discussions around the fact that we shouldn't be using a one-size-fits-all policy response to, across countries to respond to the COVID pandemic, given that policies have differential impacts depending on the context in which they are implemented. The paper specifically motivates the need to consider costs alongside the benefits of policy interventions and the need to use this information to inform policy choices. So essentially trying to move, countries away from just considering health impacts, for instance, and thinking beyond that and thinking about costs, and these are direct costs and also indirect costs, so wider economic costs. The paper has several strengths. I'll just highlight two. One is the fact that the message is easy to understand. It uses a very relevant and easy to understand metric of policy effect. So using the life saved per unit cost, unit of GDP lost, that's quite easy for both economic and non-economic audiences to understand. And another attractive aspect of the paper is that it brings together two worlds, essentially, which during this pandemic have been perceived to not always be compatible. So by combining a macroeconomic and epidemiological model, in many ways, the paper is innovative in bringing the two worlds together. Some considerations for the authors to think about. So while clearly the paper is, the foundation of the paper is the fact that there are differences between high-income countries and low-income countries. It would be useful if the paper also appreciated, or the authors considered, the differences within low and middle-income countries. So the characteristics that the authors mentioned, age structure, informality, income, capacity, are all different across, between high-income and low-income countries, but they're also different within low and middle income countries, including the impact of the pandemic. So for instance, the impact of the pandemic in countries like South Africa, Brazil, and India are quite different from the impact of the pandemic on other low and middle income countries, such as most of sub-Saharan Africa. So appreciating the heterogeneity across LMICs would be important, so that once again, we do not assume that we can have a one-size-fits-all policy within low and middle income countries. I had some concerns around the validity of the epidemiological assumptions. So while it is great that the authors have combined a macroeconomic model and an epidemiological model, one of the things that authors could consider is to think about how to parameterize and what assumptions to use in the epidemiological model. So if you look at the epidemiological literature, we have sort of global global models, such as the Ferguson et al. Model that the authors have clearly used. There's a model that has come out of the London School and so on. But then we also have models that are region specific and models that are country specific. And the general, and then we have actual data on the ground. And the general observation is that the global models have significantly overstated the pandemic impacts in low and middle income countries across most of the parameters. So the question, I guess, for the authors is how would this affect the results of the analysis? So thinking about the validity of the epidemiological model would be quite important. So an example of a paper that the authors could consider is looking at this paper that by the WHO Africa region that modeled the pandemic impact in Africa, which yielded quite significantly different predictions compared to the Ferguson et al. Paper and other predictions. And then, of course, you have local models from specific countries. So perhaps as a way of validation of sensitivity analysis, the authors could consider taking a country with good, a local prediction model and seeing whether the assumptions hold when they use that. With regard to the considerations around recommendations, again, even within countries. So in as much as the authors say that targeted interventions would be best in low and middle income countries, even within those countries, there is heterogeneity. So, urban wealthier parts of countries are different from rural informal settlements. And what we are seeing in a number of countries is that policy interventions are differentiated within the country. So, regional approaches within country have informed, policy responses. So that is something for the authors to think about as well, because even within countries, a one-size-fits-all policy or other interventions seem not to be appropriate. With regard to targeting policies, age is an important risk factor, but as the authors correctly point out, most LMICs have very young populations, and so the share of population that's above 65, for instance, is quite low. So a bigger risk factor compared to age would probably be comorbidities. There are probably more people with comorbidities compared to more people being above the age of 65. So, and the authors acknowledge that they haven't, considered comorbidity shielding. Something to consider is what does that mean for the model, given that that's a big risk factor that has been left out. The authors talk about, so the recommendation is that targeted policies are more effective. One of the things the authors need to consider is the capacity of low and middle income countries to implement these targeted policies. So while theoretically, age shielding and comorbidity shielding might be more effective, in practice, do LMICs have the capacity to implement this policy, given challenges around, for instance, inadequate information systems? So how are countries going to identify people with comorbidities? How are countries going to identify people who are old if they don't have information systems that have this data? And how are they going to actually ensure that these measures are adhered to without adequate information? So thinking about the feasibility of these interventions would be important, and how that would affect the recommendation. My last point.
Yes, can you please
Thanks.
wrap up? We only have half a minute left.
Great. My last point is around, so the authors have acknowledged this as a limitation, the fact that they haven't considered the indirect effects of school closures. We know that school closures have nutritional impacts on children, because a lot of children in LMICs rely on schools for nutrition, and also which has an impact on health and development outcomes of the children. So I guess, and then we also know that in LMICs, LMIC countries have challenges with remote